Hello, we're Team 563-3. I'm Donald, and here today are my teammates Christian, Adam, Jordyn, and Sumer. Our overall goal with this project was to create some sort of artwork or drawing using an industrial robot arm. We were tasked with designing and printing a pen adapter for the robot arm, as well as designing the artwork for the robot to draw. So for our agenda today, first we'll go over our final results, then move to our design process. After that, we'll talk about the toolpath for the robot, followed up by issues that we encountered during the project, as well as improvements we see can be done. Finally, we'll speak on our thoughts for how this project will have been having some societal impacts. So I'll go and show you this video real quick of our final project. And so now I'll hand you over to Christian to talk about our final design and assembly.
Thank you, Donald. Today I'll be going over from the initial design stage and the final drawing idea into the creation through CAD and the Cura software to a 3D printed product. As you can see here, we have the final drawing idea and the actual realization of the final drawing, our assembly part with the final pen holder with the pen inside of it, and that said pen holder on the ABB IRB robot. So for our initial design inspiration, we based our pen holder off prosthetic running blades with a certain bit of flexibility in the thinness and curvature of the blade. And our pen holder had a few requirements to it. It needed the 0.5 inch hole for the actual pen, the certain hole for the flange adapter, 2 8mm screw holes to secure the flange adapter and the pen, and a minimum thickness of at least 0.1 inches to secure the stability of the actual pen holder and integrity of the product. So this is our design realization in CAD with, as you can see, the pen holder goes through the big square bottom piece, and our flexible running blade almost idea is between the two parts of that little circular curvature in the middle. And then there's the flange adapter holes and the screw holes all implemented into our design. So after we created our idea in CAD, we exported it over to Cura, and Cura is a software that basically turns the CAD idea into a 3D printable object. As you can see here, we have the Cura opening screen with our implemented design and the Cura robot toolpath settings that we used to later print and slice this robot. Now, as you can see here, the slice of the robot shows the simulated toolpath, and that is the design that the 3D printer adds material to the actual part, creating that piece. And the estimated time was 6 hours and 6 minutes to produce this robot with 55 grams of material. And as you can see here, this is the final assembly of the pen holder on the robot. And the flange adapter connected to the robot, the pen holder onto the flange adapter with the pen inside of it. And to calibrate this robot to be printed, we had to have 3 different points of calibration, 2 of them shown here, and then 1 additional point along the Z-axis of the pen. As you can see, the Z-axis marked in our pictures. And this basically gets a sense of, so the code knows where the robot tooltip is at all time and allows us to code the drawing of the S with accuracy. And next we'll have Jordyn talking about the obstacles.
Okay. One obstacle we faced during the assembly of our pen holder was the removing of the support structures in the screw holes of our pen holder. Since these holes are much smaller than the holes for the flange adapter and pen, smaller tools needed instead of the pliers. Tweezers were the tiniest and the thinnest and strongest tool that was helpful in removing the support structures in the screw holes. Removing the support structure of the holes in the middle of our forked part was also a little challenging but manageable. The pliers could not be placed inside the hole to pull out the material at the right angle, so instead we had to push them out on one side and pull out the material from the opposite side. This process repeated for the other holes in the middle of the forked structure in our pen holder as well. Another slight obstacle we ran into was with our simulation. Our first trial run had lines in our drawing that we didn't want. This issue had a quicker solution, which is just to add some extra lines in our code that would lift the pen up to get rid of our unwanted lines. And then lastly, when we arrived to our final lab, we encountered some obstacles with our pen holder when assembling everything together. First, our hole for our pen was too large. Our dimensions seemed to be made for the large cap size of the pen, which fit perfectly, but not for the body of our pen. So to solve this problem, we wrapped our pen with tape to make its width larger in order to give it more security in our pen holder. Second, our holes for the flange adapter were too small. One of them was perfect size, but the holes in the forked part were too small. To fix this, we had to sand down a tool that would help widen the holes to be the same as the flange adapter size. And then lastly, our screw holes were too small for the screws. We attempted to use the actual screws to widen the holes, but the holes were too small and the screws were also too small to get a good grip and apply enough pressure to make the holes bigger. We solved this issue by using a drill to widen the holes, which allowed us to easily screw in the screws to secure the flange adapter and pen in our tool. And now Sumer is going to be talking about our future improvements for our design.
So as Jordyn mentioned, most of the problems we faced in our with our fixture had to do with the holes and the size of the holes. So some of the holes were too big, some were a bit small. And one thing we could have actually done to sort of help make this process a bit smoother was if we actually were able to measure our pen instead of had to work off the Amazon specifications, we would have been able to develop a more accurate design, and hence we have a more accurate part, which would eliminate some of the problems that we faced. Next, when removing the supports for the holes in our part, a bit of flash was left behind, and that later caused problems when we tried to put the screws into the part, because the flash was sort of taking up space in those holes. And so one thing we could have done to improve this was use the Ultimaker's ability to print with two materials and use PVA as the material for the support structures, and then dissolve this PVA out with water. And this would have helped the internal surfaces of the holes be smoother than it actually was. Next, one more thing that we could have done to improve the overall design of our pen holder was that we didn't take into account the possible shrinkage that could take place by the cooling of the material. So PLA has a fairly low shrinkage factor. However, it still does affect the part. So to prevent this, we could have added a little bit of extra room in certain places, such as the holes, to prevent some of the drilling that we had to do before fitting our part onto the robot. Lastly, we found that our fixture wasn't extremely sturdy because of the inspiration that we had taken from prosthetic running blade. And we have a possible alternative design that we could have implemented or could implement some other time. And it's shown on the slide. It's something that would have been sturdy yet maintain the flexibility that we were going for, and it would enable us to make more accurate drawings, as well as be a bit easier to program, just because it would be because the model is symmetrical, and the pen would be held vertically as opposed to diagonally, which we had in our pen holder. Next, we have the Gantt chart or the Gantt schedule that we sort of followed over the course of the semester. The slideshow, most of the tasks were done by everyone in the group. However, certain tasks were done by specific individuals or 2 or 3 individuals, just because of the nature of the task, and that would be significantly harder to collaborate due to software issues and other things like that. And as you can see, we are on target to complete we've already completed the first 4 projects, and we're on target to complete the 5th project on time. Now we're going to be having Adam to talk about the societal effects of the pen holder.
Thank you. So one potential social impact of a rise in robotic paintings that we discussed was a person's perception of the monetary value of art. We said that whether or not someone's perception of its value was affected would vary between someone who sees art's value in its craftsmanship versus a person who sees art's value in its emotional meaning. So an example of this would be a Jackson Pollock painting, which is more of like a emotional meaning. It's not really like high craftsmanship, versus a Renaissance painting, which is more about like the elegance and the skill of the painting. So for example, a hotel looking to buy art to put in its rooms might benefit more from a mass-produced painting, whereas a wealthy person who is looking to put art in their house wouldn't be as affected, since a mass-produced painting would not hold any emotional meaning for the consumer. So we designed a social impact study that would investigate our potential social impact. The population of our study would be people who are looking to buy art. Our hypothesis is that wealthy people, as well as artists, would be less affected than other groups by a rise in robots being able to recreate paintings identically, because they might see a painting recreated by a robot as lacking the emotional meaning that a painting by a human can provide. So the format of our study would be qualitative and cross-sectional, because we aren't going to be tracking someone's change over time. It's going to be in the form of an interview. In the interview, we will show each participant 2 paintings, a high craftsmanship one and a more abstract one. For each painting, we will ask the participant how much painting this deserves to sell for if it was the original made by a human. Then we will ask them how much this painting deserves to sell for if it was made by a robot. And next is going to be Donald, who's going to conclude our presentation.
So with this project overall, we believed we met all of our goals with this series of projects. We successfully created a pen holder for the robot. We designed the toolpath for the robot to draw our design. And we stayed close to our planned schedule throughout the entire time, making sure we were never running late. So throughout this process, we found there were a couple interesting and some challenging aspects of the project. First of all, in CAD, none of us had prior experience, so learning how to design the pen holder was a bit of a challenge. We also attempted could have attempted a much more complex drawing with our robot and toolpath design. However, we thought the coolest that you've seen throughout the slides was a cool throwback to our childhoods. It was drawn all over the place, so we figured we'd have a robot draw it as well. Learning the processes of design and engineering throughout this project really helped all of us better understand what it is to be an engineer in the future. And so this project was very valuable in that aspect. And I believe that is all we have for you today. Thank you very much.